Hello and welcome back to the Building HVAC Science Podcast. It's our goal here at BHS, Building HVAC Science, to create better, more knowledgeable HVAC and building performance technicians by helping these two professions better understand each other with the ultimate goal of making customers happy in the homes they live in and the buildings they work in. In this episode of the Building HVAC Science Podcast, Eric Kaiser catches up with Ed Janowiak at the actual ACCA 2024 conference in Orlando, Florida. Ed and Eric will take us on an audio tour of the conference, noting the mix of both technical and managerial attendees. Ed will stress the necessity of technical knowledge in HVAC, especially evident in the conference setting. Eric and Ed reminisce about their longstanding acquaintance and talk about their friendship and how these kind of relationships with a blend of technical and business acumen and professional relationships demonstrate the enduring connections that get forged within the HVAC community over the years. And I will have to 100% agree with that. Let's listen to two friends, Eric and Ed, talk about behind the scenes at ACC 2024, a dialogue with Ed Janowiak.
Well, hey, everybody. This is Eric with the Building HVAC Science Podcast, recorded from ACCA 2024 in Orlando, Florida. And with me in this recording is Mr. Ed Janowiak from ACCA, or the Air Conditioning Contractors of America Association.
I say it without the association, but I think technically the way it's spelled out is that. Okay. In fact, on my PowerPoint slides, the first time they shared the background I'm supposed to use, the first thing I did was take all those extra words. And I can tell who I shared my PowerPoint slides. One of the things we saw today with the A2Ls, they're my slides because the word's missing.
Anyway, so we just call it ACCA for short because otherwise it's a whole lot of alphabet and words, and that's too long.
So do I.
We're in too big of a hurry to say all those words. But anyway, so we're down here at the conference this year, having a good time, talking to people. This is my first time at an ACCA conference, so I'm feeling my way around here, getting to know people.
I go pretty far back. I don't think I'm exaggerating if I can say my first ACCA, that's another way it's said, conference for me was more than 20 years ago. Wow. I've also been in Orlando for one when it was over at Coronado Springs, and that one was probably like 10 years ago. So I've been to a few.
You've been to one or two anyways.
Yeah,
cool.
It's
nice.
Fun.
Yeah, it's a good vibe. A lot of business owners here.
Absolutely.
A lot of managers, and it's fun to talk to those. Normally, a lot of the shows that I do are very technical. I get to talk to the technical people, and this is a different group of people that's also fun to talk to.
Absolutely. It's a little bit different for us at this one because, as you just said, this is more along the line of the owners conference. We have another one where it's more service manager, operation manager type deals. But this one, we have a technical track, and I'm very hopeful that we're going to get good attendance in them, which is going to lay the groundwork, because when we can have technical topics here, I think it's something that people want, and it's a good place to display it.
Well, let's face it, HVAC is a very technical field, so we have to be technical once in a while. We've got to get into technical things in order to be successful in this business, really. But for those of you who don't know Ed, let's get to know Ed a little bit better. I've known Ed for 5 or 6 years, 4, 5, 6 years now, something like that.
Yeah, it's 5 or 6.
I think we met at the first HVACR symposium that
I would
Brian
agree
did.
with that, yes.
So I guess that would be 5 years now. Tell us a little bit about yourself. What all have you done in the industry?
I'm a heating and air conditioning guy by trade. For all intent and purposes, I started out of high school. Worked for a friend of my dad's who did sheet metal, and I was doing sheet metal, and I watched these cool guys who drove around in their vans all day and smoked cigarettes, and it didn't seem like they really worked. And I'm like, I want to do that. And that's what I aspired to. And I did that for 15 years before I started to speak in front of people. And that was through RSCS. And I did a heat pump class because I had learned a few things about heat pumps. And it progressed into the next thing I knew. It was easier for me to make money talking about it instead of doing it. And with that, I happened to fall into a set of circumstances where I learned rather early in the grand scheme of things about system performance. So I was very fortunate. I had a gentleman by the name of Tom Brown from California who worked for John Proctor, who was the father of Title 24, at least on the HVAC side of things. And he showed me how to measure, if you want to get real specific, how to estimate airflow on a heat pump, and how to measure watts in the heating cycle and plot a psychrometric chart to look at how many BTUs it was making in the cooling cycle. And over the course of 4 or 5 years, I did hundreds and hundreds of tests, and I became very proficient at measuring BTUs on a piece of equipment, which I was able to parlay that right into, all right, I know what this machine makes. What does this machine really provide the house with, and what does the house need? So that laid the groundwork for me to understand Manual J. When you know what the house needs, you can determine the piece of equipment. And once you understand that whole thing with the BTUs, there's some that change the temperature, there's some that pull water out of the house. And if you can make that distinction, Manual S is pretty simple on the air conditioning side. If you don't understand anything past tons, well, you're, as I like to say, a window licker, because you don't really get it. You might be looking in, but you're on the outside, you're not on the inside yet. And then next down the line, duct design. I learned how to measure airflow before I ever learned how to design a duct. And this is one of my brags. I knew what a Pascal was and how to apply 100 Pascals as being bad before I understood what 4/10 of an inch of water column in the supply or the return was bad. So I learned things backwards, but at the same time, I was learning this stuff just coming off of using an incline manometer. I missed the whole Magni-Helic gauge thing, and then I had a DG2.
That's going back a few years.
I have a DG2 that got certified for accuracy the first time in 98.
Wow.
And then the next time it was 2001 or something.
Yeah.
And again, it's another flex, that DG2 out of the 30 or 36 point test they did, there was one that was like half a Pascal off. So there's a cool manometer that you can do things with. Again, quote unquote dated technology.
And that's from the Energy Conservatory. And
Absolutely.
They're up to the DG1000 now, right?
Yeah.
So they've gone a long ways.
I've got a picture
Probably
where
998 different iterations.
Well,
maybe not.
The DG3 was real popular in the beginning, but the DG2 is the predecessor. Now, I don't know the difference, but I do know that I have the DG2 and the DG1000 teed together, and they're taking measurements that are a hundredth of a Pascal. They're still the same. It's not until we get into a thousandths before we saw any discrepancy between the two. And then it's next to a Magni-Helic gauge that I got mounted on the return drop on my system. So it's like really old technology, but they're all reading the same thing.
You haven't stuck an incline manometer on there yet?
It's on the plenum.
Okay.
So then duct design was part of it, which eventually we're going to get to where we talk about that more specifically. But that's how I grew with all this stuff. And I've been a regular service tech for a long time. I mean, just going out and fixing stuff was part of my tenure for quite a while. But then I ended up working through utility programs where I got to do the fun troubleshooting. I wasn't going and looking at stuff that was broken. I was going into a house where the homeowner was unhappy, the contractor was unhappy, the distributor was unhappy. The homeowner was happy because they couldn't maintain the temperature that they wanted. The contractor was unhappy because they were blaming somebody other than them because the customer was unhappy. And the distributor or the manufacturer was getting involved simply for the fact that they had the deep pockets and they were on the wrong end of a lawsuit. So they would send Ed out. The system would work. I would either have to tell somebody it's not going to maintain 68 when it's 10 degrees above design temperature. But that didn't happen very often. I used to see a tremendous amount of systems, and used to and still do see a tremendous amount of systems that the first thing we do is we look at the ductwork. And I have this patented procedure that I've been using for a long time called the watch test. Are you familiar with the watch test?
I am not.
You go up to the ductwork and you find some return connections that are in the crawl space or the attic, and you shove your hand in the gap between that panning and that framing, and you can stick your hand all the way up past your watch.
Oh.
And when it's at least a 25% reduction in BTU capacity and a 30% energy penalty. And that's copyrighted, documented, all that. And if you're picking up what I'm putting down, I'm saying this tongue in cheek as far as these percentages. But in real life, we find crappy duct systems. The next thing we find is duct systems that don't move the quantity of air that's anywhere near what the system needed. And then I found a lot of systems that had the right charge in them, at least going by subcooling. Sometimes you find some sketchy superheat because there's some clogging going on, and the tech wants to repeatedly tell me that you don't check superheat on an expansion valve, which I don't necessarily agree with. But
you don't necessarily charge to it, but that
No.
doesn't mean you shouldn't check it.
You're picking up what I'm putting down. So, yeah, that's one of those things that I find really not that perplexing. As long as you have somebody that's reasonable and you can speak to them, they get it. What I have found, and this isn't just an HVAC, I think this is human nature. The less prepared, the less familiar the person that you're talking to is, and I don't want to say the more ignorant they are, but that's actually the proper way to say it, using the dictionary's version of uneducated for ignorant, the more aggressive they get. So the people, the more they want to yell back, the idea of being personal, and they start calling you names and all that. I've had a thick skin to that for a long time because people would say my favorite saying to me, and that's, "You don't understand." And I do. I'm kind of a math guy. And when it comes to all this stuff, I know it comes to math, and I can show you the math on how this works. So I'm not giving you my opinion. I'm telling you that this is what it's supposed to do. So to bring that full circle, I would go in. The homeowner would be mad when I walked in. I did not work for the electric company or the gas company, but I was a representative thereof. So they immediately didn't like me. And I would start the conversation off with, "I'm here to help. So if you're going to act like that, it makes me want to help you less." And usually within 2 or 3 minutes, I was either starting to work or I was heading out back to my car and not really caring because I already got paid. So, or at least the invoice was in and I was going to get paid whether I helped them or not. But at that point, the contractor was on my side because they realized I could help them. The distributors knew me and they would always encourage the contractor to cooperate. We figured out what was wrong. And the majority of the time, airflow problems, ductwork problems, charge problems once in a while. And then I have to admit there are going to be the defective homeowners. Unrealistic expectations. And one of my big mantras is simply, you got to manage people's expectations. So if you're a comfort advisor, a whatever term you want to use for somebody that gets somebody to sign a contract, before the system goes in, somebody has to manage their expectations. The 75 degrees indoor temperature at 50% RH on a design day is what we expect. And we want that because that's deemed as comfort, and that is something that we can make happen if we follow the rules. And we'll talk about the design series, and that's following the rules.
Yeah.
Some people have unrealistic expectations, and those expectations are unrealistic.
Well, it is very challenging when you get a customer that wants it 65 degrees in their house all summer long in a very hot, humid environment.
Right. And if you don't care about the longevity of that house, you can absolutely do it.
Yeah.
But if you care about the longevity of the house, then it starts to become an issue because you're going to start to condense on surfaces that you don't want condensation to take place. Are there ways around it? Yeah. I don't know if even with a CAC or a heat pump and a DHUM, we're going to be able to maintain 65 in a house and it not have adverse effects.
Yeah, it's going to have adverse effects unless that house is really, really designed for it.
And then we're talking about
that's a whole different ballgame.
Yeah, let's just build them a walk-in.
Yeah. You went through all that. I think you did quite a bit of teaching there as well.
Oh, yeah.
In that time frame. What do you do for ACCA now, for ACCA?
My technical title is I am the manager of HVAC design education. And I think that's pretty fitting. I do a bunch of classes, and that's what I like to do, whether it is sitting in my basement on the computer. The majority of the classes that I do are design series related. I do some other topics, but predominantly, if you want to hear me talk about Manual J for 2 hours, that's realistic, and that can be live or it can be recorded. If you want to do something that is in much deeper depth that has been recorded by somebody in the past, learn as you go type stuff, that's a thing. But my favorite thing to do by far is I do the residential design for quality installation. It's the big 3-day class. So you show up somewhere. I did one in North Jersey a week or two ago. I was in Utah a couple weeks before that. I go and we have as small as 7 or 8 people in the class, or as many as I think I had 45 when I was out in Utah. And as long as the facility's big enough, it's a non-issue. I like smaller because it gets a little more intimate and you can read facial expressions. And I'm talking about stuff people don't get it at times. And I like that frown, or it's like, come on, man, ask me the question. And I'll be more than happy to explain it to you, but somebody's got to initiate it.
You brought up this design series and you've mentioned a couple manuals, Manual D, Manual S, I think, in here. Let's talk about this design series. And ACCA has what they call their design series manuals. And I've done a little bit of work with them. You're obviously way more versed in them than I am, and then a lot of instructors even are out here. Let's talk about those design series, really what they are and how they connect. Because how many manuals are there in the design series?
I'm not going to say I specifically start off with this, but in the first half a dozen slides that I do for a design course, and it could be a 1-day class or it could be a 3-day class or a 2-hour class, I start off with a slide that shows our manuals. And I don't know the answer to that question as far as how many we have, but in the residential design, we start off with a book called RS, or Residential Systems. You live in a market where you could easily see a ducted fossil fuel burning system with an air conditioner or heat pump connected to it, as well as a boiler, as well as a mini split, and so on and so forth, different air-cooled, water-cooled, all that. There are people that live in markets where we're at right now in Orlando. The likelihood of finding in a residence a boiler is pretty slim. If you had a contractor that's in this market, the book would be able to aid them with understanding residential systems on a more fundamental level. It's not a fundamental book as far as, I don't even know if I want to use the word fundamental. I want to use the word remedial. Some of the stuff that's in that book is very remedial, and some of it is fundamental and gets well beyond that. I'll finish that thought with it's a good book. It's got some good tables, managing expectations, multi-story houses, one zone, temperature difference, front, back, up, down. So there's good stuff in that book. Then we have our Manual J, which is heat in, going in and out of the building, period. And I'm very specific to mention that. Manual J doesn't do anything beyond tell us hot and cold going in and out of the structure. Then we have Manual S, which is for equipment selection. It's just not air conditioners, it's just not heat pumps. We get into forced air as well as hydronics. It's not a tough read. It is the book that if you understand the difference between sensible and latent BTUs, it's pretty easy to understand. But if you don't, it's a real eye-opener. Then we're going to have D is about ducts, T is about terminations or drills and registers. Then we get into some stuff with zoning. We have a book that's about balancing. So there's a bunch of residential books. And then we're going to double down and say we got them all for the commercial sector too. So we have a lot of books as far as that goes. And if I get to say this 3 times in the time we spend together, that would make me happy. Any of the manuals that you pick up are not standalone books. These books are used in a progression. Now, some of them you can cherry pick a little bit and combine them, but for the most part, using Manual J, S, D, and T, they need to be used in succession. And this is going to be a little weird story that if HR emails me afterwards, I'm like, all right, I can't say that again. But I won't use real figures, but I can use numbers to do percentages. So let's just say we sell $1,000 a year in Manual J. So if we sell $1,000 a year in Manual J, and we sell $1 million or $1,000 a year in Manual D, we sell $2 in Manual S. And Manual T is like the old leisure suit. I think it's the current versions was copyrighted 68 or something. Now the properties of air haven't changed, but it does. It looks like an old leisure suit. We sell more of that than Manual S.
Really?
Yeah, and it's infuriating at times. But the reality is there are institutions that are teaching Manual J and Manual D, and everything else is off the radar. So that's where the sales go. But if that's what's being taught, that's what's being absorbed. So there's a lot of people out there that will do a load calculation, and they'll do a duct design. And maybe they're not terrible, but the connection isn't being made, and we're definitely seeing that. And we see where people game their Manual J stuff to get numbers that they like. But if they would simply use the process in Manual S, they would start to get the numbers that they like. And I'm the bridge builder there because I can show people what the right path is.
In the basic process, not counting zoning, which is
Right.
another one. And I think you've got one called LLH as well for
We do.
residential, which is low load homes
Yes.
too, which is a whole different ballgame.
Low load homes are a big pain in my something about 3 feet off the ground.
All right. But I got into doing these because I've been in HVAC and did some design work and some obviously installation and repairs and followed a similar path to yours, not maybe as detailed in some areas of it. But it amazes me, just like what you said, how many people will say, oh, I did a manual J and now I'm going to go pick my furnace out or I'm going to go pick my air conditioner out based on that manual J. But they never bring up manual S.
No, it is off of many people's radar. And dare I say, what's in that book is as, if not more important than any of the other books. And this is not a design problem. This is an HVAC problem. There's more people in our industry that don't understand the difference between sensible latent BTUs versus plain old tons than do. It's the same way, dare I say it, there's more people in our industry that don't understand a term like sensible heat ratio than do. And in my world, if you understand sensible heat ratio, you understand that when we increase airflow, the ratio of sensible versus latent work changes, and vice versa. You can make the air conditioner pull more water out if you slow the airflow down. It affects efficiency and total capacity and all that kind of stuff. But there are more people out there that work on air conditioners that really don't understand how they work. And it's funny, we were at a conference not long ago and I was talking to people whose opinions I value higher than others. And I think that's a fair way to say it. And I was apparently being way too aggressive by saying that 10% of the HVAC installations that go in, they're following some good practices. And again, the people whose opinions that I respect the most were rolling their eyes and saying, yeah, you're doubling that. It's too much. And to be very blunt about that kind of sucks.
It's kind of scary in a lot of ways to me, because if we're only doing, we'll say 10% of the installations well, that means we're doing 90% of the installations not well. And from an industry standpoint, that's a little scary.
That rolls right into people tell me I don't understand is one of my favorite things. No doubt. But the simple idea when it comes to how bad things are, I will often say nothing surprises me anymore because it literally doesn't. And that can go for everyday life. I used to be pretty bad with the whole road rage and all that. And it was like, I play a lot of golf. There was a time many, many, many years ago, I threw a club and it broke. And I realized if I'm out here and that's pissing me off, why am I out here? And one of the best compliments somebody can pay to me now when I play is I can't tell if you're making double bogeys or birdies because your demeanor doesn't change. So I'm out there having a good time. Yeah, I might throw a tee or something like that once in a while, but I'll never slam a club on the ground or any of that. So when I look at a system that's not working right, I'm very mild manner. I like the phrase of it could be better instead of just immediately telling somebody the job sucks, which this popped into my head. And I have this thing where if something pops into my head, I have to finish my thought or I stutter for the next 15 minutes. Our industry is stuck on this appearance thing. And I got to be blunt. It bugs the crap out of me because too many HVAC systems are judged on appearance, not performance. I'm not saying I want to see jobs that look like garbage, but I see on social media on the regular people making fun of a job. But the very person that's making fun of the job, if you ask them what the measured airflow, what the static pressure, how many BTU, any of that, they have no idea what you're talking about. And it just goes to how systems are valued. It's being placed on the wrong metric.
And I like a good looking job as much as the next person because it is a thing of beauty to me. Like I appreciate the craftsmanship and the attention to detail
Agreed.
that went into it. But I've seen some really and tested some really good looking systems that didn't perform worth a darn.
You got a 100K furnace with a 3.5 ton AC attached to it, and they've got a 16 by 25 by 1 pleated filter. And I don't even need to test it, and I know it's above a 0.4, and it's justify that to me. I know my velocity is above 600-700 feet per minute, or it could try to achieve that, but it probably won't because the amount of pressure drop it's creating is so high. It's creating a scenario where the airflow is deficient for the system.
Yeah.
And it's one of those, but somebody's saying it looks good. My other pet peeve with that one is it's furnace, water heater combo, vented together in a basement, and the filter slot is open. And it's backdrafting the water heater, and it's not even in people's mind for a second. It's the old 5-year-old system, and the water heater vent connector has rust on it, and the way it gets repaired is to replace it, not to find out why you're getting condensation, and it's not even, again, on their radar. But I digress. I can go down those rabbit holes.
That's
for
another
hours.
deep rabbit hole.
Yeah.
I'm not sure we have that much time here. Brian may kick his office equipment here. But so you mentioned Manual T very briefly, and I also want to talk a little bit more about Manual S, because Manual S just went through a rewrite and got re-released.
It did.
And that was exciting to me because there's a lot of new things in there about sizing heat pumps.
Oh, yeah. Really good stuff going down that road.
Good stuff about sizing heat pumps for cold environments, colder outdoor environments, and dehumidifiers.
Yep.
There was a lot of really great updates in that manual, and I was excited to see that get released. But Manual T, I'm going to say I don't hear a lot about that manual either.
Bluntly, the majority of our grills and registers get selected based off of cost or appearance. I'm comfortable saying that's a fact. But what we're really trying to do is select real simple. We'll get grills out of the way. Return grills, you put them in big enough so that they don't hum. And you know why return grills hum, don't you?
I'm not sure I know the answer to
Yes,
this
you do,
one.
but thanks for letting me say the punchline. It's because they don't know the words. Everybody's
go.
been in the
Ba-dum.
house. Yeah, everybody's been in the house with the spaceship noise where they're going, woo.
You lay your hand up on it and it suddenly stops. You're
See,
like,
in my
oh,
world,
yeah, uh-huh.
you grabbed the kitchen chair and you took your Leatherman out and you stood on it and you bent them straight, and that would reduce the sound. It's velocity noise because the speed at which the air is moving across them is causing them to vibrate. There's rules in Manual D, which really come from Manual T, that it is a simple stamped steel bar grill. The cheap ones, 500 feet per minute is your maximum velocity across them. You can do some math and figure this out. You get your favorite brand of grill manufacturer, and they have rules in there you follow. They don't make noise. On the supply side, our registers, we are going to adjust or manage. That's the word I want to use. We're going to manage the throw, the distance the air comes out, and the spread, how it gets coverage along a wall or across the ceiling or in the room. But we're going to manage that throw and spread based off of the volume. And for those people sitting in the back row, I'm going to say it again. We're going to manage the volume going through the branch run with the damper that's going to be connected. We manage the volume, not the velocity. There is this misconception that we're trying to control velocity in ducts at times. We're always trying to control our velocity, and we have a limit. In the supply side of the system, we want to stay under 900 feet per minute. Hard stop, period, that's where we do it. The conclusion of Manual D specifically says that, and I think I'm even nailing all the words. No, I'm not, because I can't remember the first couple words. But to paraphrase it then, it says that when you're designing a comfort system, the velocity of the air through the ductwork, or through the airways is the actual word that's using, there's no minimum velocity. It's not a thing, because 120 CFM that we're routing through a branch run is 120 CFM if it's a 6-inch, an 8-inch, a 10-inch, or a 12-inch. Obviously, the velocity is going to be much less as the ducts get that big, and we're never going to use a duct that big. But it's to emphasize the point. If the volume is correct, when the air eventually goes through the boot and out the register, we're going to get that predictable and throw and spread. My analogy is the air going through that branch run is a garden hose, and we are setting it at a very specific GPM or volume. Mm-hmm. And we're putting our thumb over the end of the hose. We get the throw and the spread with our thumb, and it doesn't matter if that garden hose increases 2, 3, 4 times, as long as the GPM remains the same. The volume of water going past your thumb, as long as your thumb didn't move, is going to remain the same, because the opening has to stay the same. So you could have a 12-inch duct or a 6-inch duct feeding into a 10x4 boot, and it would look funny. But still, it's going to go through a 10x4 opening and across the grill, and we're still going to have 120 CFM of volume going across it.
And then the throw, of course, is going to depend on what size the register is, how the register is configured, what direction the blades are aimed, all that neat stuff.
That's the selection part. So if, for instance, if you're in a market where you want the stuff like this is one of my favorite systems. We're blowing it out of the ceiling. And I have two choices. I'm either going to do a perimeter. So I'm going to squish my plump body out towards the eave and trying not to get nails in my head. And I'm going to put 10x4s or something fancier, but let's call them 10x4s out around the perimeter in front of the windows. Actually, I'm not going to do that. I am going to use a different style register that's chosen, and I am going to put it near the interior wall. Nice short ducts, that's more better. I don't think anybody will argue that, especially if it's an unconditioned space, but less material is good.
Yeah.
So I have that short branch run that goes into my properly chosen box size. My register is chosen based off of the idea that I want that air to come out of it, and I want it to travel 3/4 of the way to the exterior wall. So for round number purposes, let's call it a room that's, say, 12 feet across. So I'm going to come in a couple feet. I'm going to pick a register with 7 or 8 feet of throw. That's going to get me 3/4 of the way across the room. And in that last 25%, that's where the air is going to be able to start to lose its momentum. That distance from where it starts coming out of the register to where it hits what I'm going to call the end of its throw, it's not actually the end of momentum. It's when we hit a term called terminal velocity. And terminal velocity is essentially where you've gone from 500, 600, 700 feet per minute. 700 is a pretty common number for the selection of the register from the manufacturer's data. But when we hit that terminal velocity, we're somewhere around 100 or 150 feet per minute. We're not out of momentum, but we're getting there. Then the air tumbles down the outside wall with the intention of not blowing air on people. And that's one of the other big things in manual T. It's about blowing the air around the room, but keeping it out of what is referred to as the occupied zone. And the occupied zone is simply 2 feet off the exterior walls up to about 6 feet. It's where people occupy. And if we keep the air movement to a very minimum amount inside the occupant zone, we don't blow air on people. You don't blow air on people because they notice it. And one of the definitions that you can find in Webster about comfort is not being aware of your surroundings. And if you're not aware of your surroundings, you're comfortable. That could be feeling the draft. That could be hearing the noise coming from the system. Goes back to the spaceship noise and all that stuff. So comfort, feeling safe. I don't know if your HVAC system is going to do that for you, but it can definitely be audible in a positive or negative way. And we can make it so that we don't blow air on people. So this is another one of those deals. Everything that I just spoke about is math. This isn't my opinion. This is something that we can use math. We can use some charts, and we can bob and weave a little bit. And I'm here to tell you, if I can figure this stuff out, anybody can figure this stuff out, because none of it's hard. It's a bunch of little pieces you got to put together, but at the end of the day, none of it's hard.
So it's really safe to say that before somebody can do a manual D duct design, they really need to do a manual T to figure out what size registers need to go in and what size boots should be put in.
Without question.
And that also, your boot location determines the length of the run that's going to the boot.
The order of the design manuals has been screwed up for a long time, but there's reasoning behind it. People used to say JDNS. Mm-hmm. The first book that was adopted by code was J. The next book was D. The next one was S. So JDS makes sense. But that was one of the first things when I came here. Everything that was in print for advertising and all, I put them in the correct order. Now, I can find some older stuff that was put in the correct order. And the correct order, as you're saying, was J, S, T, D. That's the way you do it. So the top three, J, S, and D, are part of the code. And the code means ICC or IAPMO or wherever you are in the states and surrounding areas. But they're all part of following the code. The important stuff in Manual T is in Manual D. So it is Manual T stuff, but I guess if you really want to get into the specifics of it, it's listed in Manual D. So that's how it's covered. But it goes back to the very premise of that predictable result stuff. If we follow the design series from the beginning, the BTUs in and out, can be calculated in a way that we can work with very well. Make no mistakes, the results from Manual J can be explained in Manual J, and we hear from people time to time that will criticize the way Manual J does stuff or the results that come from it, but all those people are doing is screaming, I never read the book, and I'm going to expect it to do something that it was never designed to do. But we start off with Manual J, then we select our equipment with Manual S properly. And again, that could be for cooling with a CAC or a heat pump. It could be with fossil fuels. It could be a bunch of different ways. It also tells us what our airflow is going to be, because when we look in the expanded performance data, it tells us what those sensible and latent requirements are and the associated airflow. So that's how we figure out what our airflow is. To your point earlier about the new Manual S that's coming out, and you got a lot of class, man. You never said, and I'm in it. You're in it. Congratulations.
I am. Thank you.
You should be very proud of that.
I was very proud of that. This is the first one I got listed in.
Yeah, so it's a big deal. So being part of the process, and it's whether people realize this or not, it's an acknowledgement that you contributed. It's not that you were just amongst a group of people. It was something you said helped guide the document that we have. So it's a big deal. You should be very proud of that. So anyway, the stuff with S with the heat pumps, it's due. Heat pumps can be used for heating in, I don't know if I'm going to say every climate, but almost every climate in its entirety by itself. And in many climates, it can't be, but we got people trying. So we're doing everything we can with Manual S to make it so we're separating sensible and latent BTUs. And if somebody will follow our guidance, it's going to work. If somebody does something else, I don't know what's going to happen. Yeah. And I kind of like it like that. So then Manual T, we're going to select the throw and spread that's required for our design from the specific register and grab some grills that don't make the spaceship noise. And
don't blow air on people.
Don't blow air on people.
This was one of the first lessons that Ed taught me. Like when I first got to know him, he was don't blow air on people. And what I took away from that was blowing air on people typically makes them uncomfortable.
Oh, yeah.
And it's especially important today because we've got a lot more heat pumps going in. And if you blow heating air out of a heat pump, which is typically a lower temperature and higher volume than a lot of the gas furnaces we're used to, you blow that air on people, people are going to be unhappy.
I agree.
And they're not going to have much fun.
The next one in succession, whenever we talk about blowing air on people, is mini splits. And it's bizarro land because the mini split manufacturers used to brag about how the fans went back and forth and did all this stuff, but they're blowing air on people. Fast forward a couple of years, I'm at ASHRAE or AHR, and there's a company that has this thing that clips on the front with all these little holes. And the point is, don't blow air on people. And I still chuckle about that one.
Wow. I have a ductless split in my office. I hear the term mini split a lot, and there's ducted mini splits and ductless mini splits now. So I don't know, that term doesn't mean the same thing to me that it used to when they first came out. But I have a ductless mini split in my office that has an infrared sensor on it that will take the air away from the places in the room. Wherever the person moves in the room, blows air away from
They're following the rules.
I was like, wow. Now, it is that sensor, when I sit in my office, because it's really quiet in there because I have it soundproofed well, it is noisy as all get out, and it drives me absolutely bananas.
Really?
Yeah.
Now,
the little motor in it that runs it around drove me bananas. I finally had to turn it off.
Wow. That's a little disappointing because that's a really good idea, but if it does the exact opposite effect, because the whole reason you're putting that evaporator in the room, or condenser, I guess if we're talking about a heat pump, in the heating mode, you put that in there and it's nice and quiet. There's no getting away from, they're not magic, but the way they perform compared to a lot of ducted system is nothing short of magic, because putting the evaporator in the space to be conditioned, that's the way to do things.
You don't have duct loss.
No.
There's no duct leakage. There's no duct loss. It's very easy to seal up. It just works well.
That's the way to do it.
In a lot of applications. Now, as with anything, there is no magic bullet out there. It is not the perfect piece of equipment for every application on the market.
I agree. They have their spot, and they're another product with the whole thing with the heat pumps and the electrification and all that. I think we have the ability to fend off some of the bad stuff, but some of the stuff I see coming down the pipe, shouting from the mountaintops. Use heat pumps wisely.
And that's where RS comes into play.
Yeah.
I think. So if we're talking about residential, with a lot of people that listen to this podcast are residential designers or have something to do with residential HVAC, use that RS in order and then do your J and then do your S and your T and D. And then at the end, we want to do the balancing, right?
Yeah.
There's test and balance.
Yes. One of my favorite lines, and first time I heard it from somebody was Alex Meany saying it when we were down here in Florida a couple of years ago. And he was like goofing with the mic going, "Look it up." Because somebody would ask a question and they were asking generic questions that the only way you would know the answer is if you got the book out, the expanded performance data for the equipment, and looked it up. So a lot of this stuff is you can't just give generic numbers. I mean, you can ballpark stuff, and we've all installed stuff based off of ballparking, but why would you ballpark something if you don't have to? I want to be able to get all the topics that we were originally discussing within our time. So the last one that I wanted to talk about is Manual D. And we spoke about that whole volume going through the branch runs and all that. But this is one of the things when it comes to Manual D that a lot of people maybe aren't that familiar with. And I have two schools of thought when it comes to explaining Manual D to people. If I have somebody who is as big a dork as I am, and I'm going to say we are, you want to understand stuff from the beginning. You want to understand how a fan actually, it sounds like thunder. Oh my goodness, why is it so dark outside? Why does that plane, oh, never mind.
Not sure what's happening around us, but it sounds like a wall maybe falling down somewhere.
It does. So if you want to really understand this stuff from the beginning, that is funny.
Yeah. There's a herd of elephants coming up the escalator right behind us.
It was them.
Yes.
Okay. So if you want to understand it from the beginning, you want to understand that when you shove air through a duct, that the more you shove, the more mass that goes through the area, the higher the resistance to it there's going to be. The same way when that mass increases, the resistance to it can be measured. So we can look at a blower curve and we can see what happens to the airflow while this whole thing is taking place. It's pretty fundamental. There's a chart that's in the beginning of Manual D that I have seen for a long time, and it makes me chuckle because I looked at that chart for a long time and I never understood it. But I am a follower, so to speak, of if I use something and it works, I don't care. So I used Manual D and I followed the rules for a very long time and never really understood some of the background behind it. I've laid out more ductwork on a piece of scrap wood or a piece of cardboard on a job where the house was framed, and I can do the friction rate worksheet and do all that kind of stuff from memory, just from pure repetition.
So you do field CAD.
Yeah, it'd be a really good way to put it. And
cardboard aided design.
Yeah. I'm very proud of having a 2x8 that has a duct drawn on it, right? Because I can do that. And it's once you understand this stuff, it's super. Well, it's like anything, man. It's you know how to tie your shoes. You're an expert, so it's very similar. But when it comes to doing this, I believed in it so heavily because I knew the results were always your external static pressure was always lower than what your original design was, as long as you followed the rules, pulled the flex tight, if you used it. One day I was talking to Steve Rogers, and I said something about that chart. And I said, I don't understand it. I don't care. And he's like, do you want to understand it? And I was like, yeah. And he explained the whole, or when you shove more air through the same size duct, the friction goes up. And where the two lines cross, that's what you're doing on a fan curve to plot it. And I was like, oh, that's all they're telling me, isn't it? He's like, yeah, but it's just not how you look at it when you're picking a blower for a furnace. It's just showing you where the two things intersect. And in my world, those two numbers I would need didn't intersect on that chart. It didn't immediately click. I ignored it. So this is all to say, when I teach Manual D, I tell people I didn't understand a lot of this stuff in the beginning for a long time. I don't care if you do or not. What I do know is that particular book has 3 charts. And if you follow the instructions, if you grab the chart, the first chart tells you to figure out your worst duct, your what they call the critical path. It forces you to gather everything. If you figure that out, which ironically, step 1 is to do step 4 on another one of the worksheets, which I'll never stop finding is funny. But then you grab the next sheet, which is the friction rate worksheet, and step 1 through 5 It's like programming a modern thermostat where all you're doing is following the prompts. It's exactly what the friction rate worksheet is. You ask you airflow. I got that from Manual S. What's my external static pressure? I got it from my blower data. Step 2, what are my pressure drops? It's a furnace coil combination. I grab my coil, I'm putting a filter in it, 1 supply grill, 1 return covering, 1 damper. Because remember, it's the critical path, that 1 duct run that's the longest circulation path. So I pick all the things that are going to steal my oomph. That's a technical term for pressure. So I'm going to come up with my available static pressure, which is external static pressure less your device losses. My available static pressure times my total effective length, which was my initial worksheet that I completed. And with that, it tells me what my friction rate is. Friction rate is literally rate of friction. It's pressure drop per 100 feet. If you understand that, great. If you don't, I don't care. I want you to take that friction rate number that you calculated. Did you get calculated? You didn't make it up.
That's the friction rate on the duct calculator that we all use, and everybody sets at what?
0.1 or 0.08 or whatever fictitious number.
And that changes from system to system.
Yeah.
That's not a fixed number that we should be using a fixed number.
Exactly.
It's got to change.
And if I must, very briefly, if you use some of these numbers, especially anything that starts with a 0.0 something, you're going to have enough area in a duct system to support a proper duct system where our velocities will be in check. Under 700 on the return, under 900 on the supply. But what you completely miss the boat with, when you calculate friction rate, the other part of the process is to see how much pressure we have to start. And if you're just randomly making up friction rates, you could have a system that will never work from the day it's installed because the fan power that you're starting with is inadequate. You could have pressure drops that are too large, which is really common because people don't calculate filter pressure drops. They just say, oh, 0.1's good. I'm familiar with that. And they plug it in. And the reality is it's 0.4 or greater. It's a process of calculating something. We took step 1 through 5. We came up with the results. We took our duct wheel. We designed a duct system. And everybody knows how to do that part already. Chances are,
theoretically.
They're making stuff up before they get to that. But now they're back in their comfort zone. They know how to do it. So what we end up with is a duct system, because earlier we talked about manual T and we picked the right terminations. And what we now have is a heating and or cooling system that has been selected based off of the actual requirements for the structure. The terminations were selected properly. The ducts are of a size that we can deliver the proper volume to every branch run, and they don't require anybody to turn the TV up because it's noisy. The air doesn't blow on anybody, and it works with what is my goal all the time. It works with predictable results. So when you tell somebody, I'm going to charge you $18,500 to put this in your house, you know at the end of the job exactly what it's going to do. There's no hoping or anything like that. And with confidence, you can tell somebody, this is what I'm going to deliver to you. And in my world, it's how you justify charging, 20% or 30%, or it makes you competitive compared to somebody else, especially when you can ooze with the confidence that this is what this system is going to do. I don't like throwing other people under the bus, but at the same time, I never had a problem with just bluntly telling people, this is what's going to happen because I did the proper calcs ahead of time. It's like a house that is having duct issues and you take some measurements and you see all the woes are on the return side. You crack the door open on the furnace and it replicates that in the return and you see all your numbers fall into place and you're like, all right, it's $1,200 to fix it, but it's going to fix it. It's not, I'm going to charge you X amount of money and we're going to try and see if it works. As a consumer, I would never shell out somebody trying. But if somebody can replicate it, then you go with them. That's what proper design is about. You can do a proper design. You simply don't make stuff up, and you'll get those predictable results.
And that's provided that the design actually gets followed at installation.
Yeah, that's a little bit of an issue at times, too.
That has happened once or twice.
Yeah, and we could go on for a long time about things like using flex duct, and is that actually installed properly? And I like flex. And I'm one of those people. I like all duct systems. I like duct systems that provide the design airflow. I don't care about the material. They can all be, they can be installed properly, and they can all be installed like crap.
We've all seen bad flex duct. We've seen bad metal duct. We've seen bad duct board. It doesn't matter if it's not put in a way that delivers the airflow. It's just a bad system. It can look as pretty as it want, but if it doesn't deliver the design airflow where it's supposed to go, what's the point? Well, anyways, I think we're running up on towards the end of our time slot here in the booth. So any last thoughts you want to share with everybody?
Well, I'll always plug an advertisement or a minute or two for the classes. If you're interested in learning about this stuff, and the way I describe it is, if you want confirmation that you're already doing it right, hang out with me for 2 hours on one of the JD or S classes. If you want to get into humidity, I do an hour and a half Zoomie on a class that we call humidity. And do you know why we call it humidity?
Because it's full of, if it's all wet? I don't know.
That would be good. But no, we called it psychrometrics and nobody showed up. When you call it humidity, people are interested. So that's pretty cool. We got some other fundamental stuff where we talk about furnaces and boilers and basic fundamentals with air conditioning and all that. That's fun. But more so back to the JD&S stuff. If you want to learn more, I even did the JD&S thing. I fell right into it.
You did it right there. It's
old habits.
Right there.
So if you're interested in that, you can look at something that's recorded. There's a lot of content on our website. The one part, and I am not hawking this, but if you're a member, we have a whole bunch of stuff that's behind the paywall. So that's something you have to keep in mind. If you use code ED100, you get $100 off a membership if you're interested in that.
Wow.
And I'm not trying to hawk membership. I'm trying to save people money. That's how that goes. But there's a lot of good content. And I'll finish this one up with, I don't care who you learn this stuff from. Learn this stuff, because if you want to sleep good at night and you don't want to worry about duct sweating, the TPC is one of my favorite topics. And if you're not familiar with the TPC, I used to do a class that I had to kill 45 minutes before I started. And I would talk for 40 minutes about the TPC, and all I'm talking about is that phone call. And that phone call is all about people complaining. And if you manage your expectations, they start talking about things like, that thing runs all the time. You know the proper response. Do you know the proper response to somebody who says it runs all the time?
Is it comfortable in the house?
You hug them, right? And you say, congratulations, you own a proper system.
All right, folks. On that note, we're going to cut this off here. Thanks for listening to the Building HVAC Science Podcast. And Ed, thanks for joining us.
Oh, thanks for having me. And anytime.
Thanks for listening to this episode of the Building HVAC Science Podcast. You can follow us on Facebook, looking up Building HVAC Science. You can also check into what we have going on at True Tech Tools. The Building HVAC Science Podcast is, of course, a production of True Tech Tools Limited. Full disclosure, I'm a co-owner of True Tech, and the opinions voiced are those of my guests, my co-host, or myself, depending on who's speaking, of course. And if you're looking for or in the market for tools or test instruments, take a look at what True Tech Tools carries, TRUTECHTOOLS.com, and you can use the offer code HVACBS for a nice discount. I want to thank you for listening to this podcast, and if you've not subscribed, please consider doing so. We welcome feedback, and you can send that to marketing@truetech.tools.com, MARKETING. I really didn't have to spell that, did I? At truetech.tools.com, TRUTECHTOOLS.com. Thanks for listening again to the Building HVAC Science Podcast, and we'll continue to work on bringing more great content right into your ears. Take care.